Hi, my name is Steven Feuerstein with a beard. Hope you like it. I just decided I don't want to shave anymore. We'll see how long it lasts, but it's the new me. It's the end of 2018 me. So thanks for joining me at this latest AskTOM Office Hours session, in which experts from within the Oracle database team make themselves available to answer your questions, present their ideas, and so on and so forth. This is a AskTOM Office Hours session on PL SQL because I'm doing it, and that's pretty much all I know. Chris Saxon usually joins me on these sessions, but he's at the UK OUG conference. And by the way, he was just given an award yesterday for the best Oracle speaker from last year. Very cool. Congratulations, Chris. So what I'm going to do, what I decided to do is set as the session or the topic for today, PL SQL guilty pleasures, things we like about PL SQL, maybe we shouldn't do. I'll come back to that in a second. You can see on the slide all my contact information. Follow me on Twitter, check out my blog, videos, and so on. Now, in terms of the AskTOM Office Hours program, just a quick reminder. So you can come to asktom.oracle.com, click on the Office Hours tab. You can see all the office hours that we offer, many, many topics across many aspects of Oracle database. We encourage you to sign up and attend many of them. Direct access to product managers, developers, developer managers, evangelists, and so on. Great program. Thanks for taking advantage of it. In addition, check out the Dev Gym, where you can take workouts, classes, and quizzes on a variety of database and other topics. We've recently added a Java quiz as well. So if you want to spiff up your knowledge about Java in addition to SQL, it's the place to go. And of course, as Oracle Live SQL, we'll be using this site once again in my session to explore some of the features we'll be talking about. One other thing on the Office Hours page, when we're not in the middle of the session, you can also submit questions on the page, and then we will answer them either in the session or privately, or publish them on AskTOM. And you can also manage your questions within Office Hours by going to the My Questions page and then making changes or submitting new questions, etc. All right, so PL SQL guilty pleasures. I must admit, I came up with this idea. Let's stop the share for a moment. So I must admit, I came up with the idea for a session on guilty pleasures because it's the end of the year and I was having trouble deciding on a specific topic that I thought would really engage everyone. So I thought, let's make it a little bit miscellaneous. And what I realized afterwards, when one of the members of our community, Denis Savenko, and he's on the call, on the session, submitted his own guilty pleasures, that I wasn't even thinking about the term properly. So let's take a closer look at guilty pleasures. So what's the definition of guilty pleasure? Well, one of them, the shortest one I can find, something that brings pleasure, makes you feel good, but it's considered taboo or unadvisable or lowbrow. So in other words, it's something we do that we probably know we shouldn't do. Why do we have guilty pleasures? Because programming should feel good, and I think for a lot of us, it does feel good. You get an enormous amount of satisfaction out of solving problems, writing code. But I must confess that when I first came up with my list of guilty pleasures, they really weren't guilty pleasures. You'll see them later on in the session. They were really things I like about PL SQL that I wanted to share with you. So I decided, since Dennis took the time to write up a bunch of them, I thought we'd start with his guilty pleasures. First guilty pleasure, implement functions and procedures which expect all values for their parameters, which are translated to attributes, I suppose, if you had an object type instance. That leads to the fact that consumers should think about the lost update problem. In other words, if I don't pass in a value for every parameter value, it'll wipe out the values currently in the table. But consumers are so lazy that it would be a much better idea to implement routines in a way that they expect only the changed attributes. In this case, the lost update problem would not exist for the consumers, but the routines would be a bit complex, more complex. So let's take a look at some of my code, which as you guys probably know, I am ready to do, to get a sense of what Dennis is talking about here. So I'm going to bring up my QDB Content Manager package. QDB is Quiz Database. It's the backend for the Dev Gym. I'm the main backend developer at this point. Let's take a look at, I believe it's called Insert Question. Here's Insert Question. And you can see, so when we create quizzes, the question is at the core of the quiz, we have to save it. So here's an example of one of those procedures that allows you to insert a question. You can see all these values with nulls, nulls, and nulls, and they go into the table. So that's the insert. Let's look at update question. Update question. So here are a bunch of input values, parameters. Notice default, null, default, null. And what I'm doing eventually with a lot of other stuff going on somewhere in here, there's an update. Here's an update statement. And I'm overriding all the values for those columns. So on the one hand, this is great that I've got this one procedure that allows you to pass whatever values you want, and we don't have to have 25 variations. The problem is that somebody has to remember when they're doing the update to provide all the existing current values across all these different columns. Otherwise, they'll be wiped out, they'll be set to null. Now, this works okay in the context of how it's being used, this kind of update, broad update procedure, because it's being called from within the Apex app, and all values from the page are being supplied. But you might also want to have smaller updates. So an update question that only has 3 different parameters or 3 different columns being updated for specific purposes. And those are called in place of this big one. Otherwise, if you wanted to call this big one, and you only wanted to update 3 columns, what would you have to do? You'd have to select the row out of the database, use that record, and then override the values in that record for the specific input values and the parameters, and then apply the update. You can do that, but it's often better to create these smaller, more customized entry points. Dennis, I hope that caught the train of thought there, and I don't see any more comments, so I'll keep on going. Next guilty pleasure from Dennis. I don't want to think a lot about how big my string variables are or going to be. So just go for varchar2 32767. But it's a much better idea to specify the needed length or even use an anchoring data type. And conversely, don't think a lot about how small my string variables are. Just set them all to varchar 32767. When maybe, if they're going to be big, we should use clubs and then not worry about even that maximum constraint. So let's talk about this for a moment. Again, I know exactly what Dennis means, because as I'm writing my code and I start to write varchar2, I think to myself, what should the value be? Should it be 100, 500? Just make it 32767. Now, in my code base, I have a package called qdbconfig, my overall configuration package. And I have in here a subtype called max varchar2. So Dennis, I agree with you. Why not just make things varchar2 32767, unless we want to anchor them instead? But here's the thing. I don't actually hardcode varchar2 3267. That's a step a little bit too far for me. So what I'll do instead is when I declare my variables, and let's see if we've got one in here. Oops. There we go. So get the domain admins. For a given domain ID, I'm going to use list add and produce a comma delimited list of the user IDs of the admins for a given domain. For example, Kimberg Hansen is our SQL quizmaster. He's the domain admin. So I'm going to return a string. So I'm going to have a return variable. What's the maximum length that I should set it to? It could be really big. Actually, it might not be really big at all. But I just say max varchar2, and then off I go. Now, I like this better than varchar2 32767 because I don't want to hardcode that limit. It's certainly possible that any future version of Oracle, 20C, 21C, there are so many years to choose from now, that will decide that varchar2s can be 64K in length, or maybe there'll be no difference between clobs and varchar2s over time. So I decide to use a subtype with a name that expresses what I'm after instead of the actual length. Now, you might say, but Steven, you might be wasting a lot of memory there. If you only need, for example, what's the list of user IDs? Even if there are 100 user IDs, 10 digits each, that's 1,000. I could have just made this varchar2 1,000. Wouldn't that be better? Well, I'm not sure why it would be better. Here's the thing. You're not using more memory by declaring things max varchar2 32767. In fact, you're using more memory by taking this approach, because the algorithm inside the PL SQL engine says that if your varchar2 length is 4,000 or less than 4,000, then it's considered a small string. And rather than allocate memory incrementally as you change the value and maybe make it bigger, it's a varchar2 variable length string, it'll just allocate the full 4,000 bytes right at the start. So by declaring it as 1,000, I actually use 1,000 bytes of memory. If I declare it as varchar2 32767 or 10,000 or whatever above 4,000, then we don't allocate that memory in advance. So you don't have to worry about using too much memory And I definitely don't think you should do this, like Dennis says, it's a guilty pleasure. It's faster to type. Because then you're hard coding the limit, and people are asking themselves, why would you make it so big? So a couple of thoughts there. And something from Dennis, he calls them PL SQL string and SQL string for 32,767 and for 4,000, right? So he might have, so his is PL SQL string and then a varchar2 4,000 for SQL strings, because still, well, not still, you can now extend the maximum size of a varchar2 in the database to 32,767 by setting a system parameter when you create the database. So you're no longer stuck with a 4,000 length, but it's certainly a common thing in the past. All right. And that's right, Judith, the border value around low or high, whether to allocate all or save till later, used to be 2,000. It was moved up to 4,000 in 10G, I believe. And hopefully you're all on 10G or higher. Back to the world of PowerPoint. And then the other one here was about, something being, worrying about getting past 32,767, make it a clob instead. Fortunately, in terms of varchar2s being easier, my impression these days is that varchar2s and clobs, you can manipulate clobs with a lot of the built-in string functions now, like substring and instring, that you couldn't do originally. So they've gotten pretty easy to work with compared to the past. Moving on. Another guilty pleasure from Dennis. Don't think a lot about your dates and timestamps. So just go with dates because they're easier to use than timestamps. Unfortunately, as he points out, eventually you come into time zone management hell, and then you really pay for the price of going with dates instead of timestamps. And boy, I got to tell you that this really rings true for me. When we built the Dev Gym, originally the PL SQL Challenge back in 2010, which is a long time ago now, but certainly not for dates versus timestamps. Me, the old school guy, went with dates instead of timestamps with local time zone. And it does make things more difficult to manage and really provide the optimal user experience. So I encourage you, if you're not already familiar with timestamps, check them out before you work on your next application and use them instead of dates. Another guilty pleasure. Use magical ad hoc literal values instead of constants. Yes, this is especially good because, of course, it's one of those situations where we don't want to have to type out the name, create the constant, and then type the name of the constant, and instead just put the value there. I'm only going to need it this one time, and I'll always remember what 47 means, or ABC, or whatever. What do you mean I'm not going to remember it a year later? Come on, I've got a better memory than that. So I'm sure you've all run into this problem. I think that I mostly violate the rule around constants with yes and no. So if, again, we go back to QDB config, we should find a yes and a no. Yes, I actually did this, you see. Yes and a no constant. So that throughout my application, I could do C underscore yes, C underscore no, and make sure that I don't use yes and no, the whole words versus Y versus N, 1, 0. And I use it a lot in the application, but at some point I just sort of broke down and stopped using the constants instead of the values because I realized there's no way we're ever going to not use Y and N for our yes and no values in this application. But I really shouldn't do that. And so in that sense, it was certainly a guilty feeling. I'm not sure how pleasurable it was to write Y, but it certainly made me feel guilty, made me feel bad about what I was doing. Okay. One approach you might take with dealing with these kind of magic ad hoc literal values is to give them crazy values that nobody would ever use. Yes, indeed. No way. Now, if these are my yes and no values, then there's no way that I'm ever going to not use the constants because I'm not going to type all that, and it's just weird. It doesn't look right, so just yes and no. But it probably makes more problems than it's worth to do that. And Sven says, I find reading the code is easier when the literal value is used instead of a constant. Well, Sven, it's a good point. I think it's a point that can be raised generally about encapsulation. If you hide things from view, then there's a trade-off. You're presented with less information, with less that you have to evaluate. I'm thinking about things like queries, for example, select statements, hiding them behind a cursor. But you also lose the visibility of that information. What is my query doing? In terms of ad hoc literals, yeah, I don't know. I mean, for yes, in most cases, it seems like the name given to that literal might be more expressive, or should be at least as expressive as the value itself. So I'm not sure why necessarily you'd lose all that much readability. Of course, it would be package.constant versus just the value. It doesn't seem like it's that much of a distinction. And Sven points out that it has to do with highlighting in your editor, so that, for example, in SQL Developer, you can see that my literals are highlighted differently from my identifiers, so they stand out better in the code. That's a really good point. Yep. Obviously, at some point, it's a matter of preferences, and if you like to see it saying equal Y instead of equal yes, go for it. And of course, as you probably know, if you write a SQL statement that's executed outside of SQL, and a SQL statement executed outside of PL SQL blocks, then you can't reference packaged constants. Hopefully that will be addressed at some point in the future. I cannot give you any specifics on that one, but that'll be really nice to see. All right, moving on. And the final guilty pleasure from Dennis, my favorite, because it's quite difficult to catch. Do SQL stuff in PL SQL, do PL SQL stuff in SQL, and maybe have them call each other. So it's really good to use a tool for the stuff it was made for. SQL and PL SQL are very close, very tightly integrated. But Dennis points out that you can often do it in pure SQL instead of bringing in the PL SQL constructs and overhead. And certainly that's the thing to do. But that's not the only thing to watch out for. If you've got SQL calling PL SQL calling SQL, you've got context switching issues, performance, and possibly read consistency issues. Let's take a little bit of a closer look at that. And then I also want to come to the point of quite difficult to catch it. Peter, I just saw your comment, plus using ORE from PL SQL. Sorry, what do you mean by ORE? Oracle R. Oh, okay. All right. So, so in terms of SQL and PL SQL and calling PL SQL from within SQL, calling SQL from within PL SQL, obviously, one of the beautiful things about PL SQL is its tight integration with SQL and how easy it is to write SQL statements. And it's easy to extend the SQL language with your own user-defined functions. There are a couple of things you want to watch out for. First of all, generally speaking, you don't want to create functions in PL SQL that in turn call SQL, especially when they're being called from within SQL. And one of the reasons you want to watch out for that, and this was covered in one of the quizzes in the DevGym, which is what this code comes from. If you ever see examples that start with QZ or PLCH for PL SQL Challenge, they originally came out of the PL SQL Challenge and DevGym site, which means you can go to the site and take these quizzes. This actually goes through the steps of showing how you can run into problems with read consistency. So I'm sure you know that when you execute a select statement or execute any SQL statement, for the duration of time that that statement is executing, changes that are made in other sessions and even committed are not visible to that statement. In other words, it's consistent from the point at which it started. All the data is kept consistent, which is really fantastic. If I have a report running for an hour, and halfway through somebody deletes all the rows in the table, I won't notice that. It'll just keep on going, and hopefully we won't get a read consistency error, snapshot too large and so on, or snapshot too old. Here's the thing though, if I call a function inside my select statement or my SQL statement, it is not, the contents of this function are not a part of the read consistent image. So any select statements that occur here do not reflect that starting point of the outer SQL statement. So in general, you always want to be careful about calling PL SQL functions from SQL because there's a context switch and overhead involved. But most importantly, look inside that function and make sure it's not itself calling SQL. And if it is, ask yourself about read consistency, whether or not it could be a problem. Okay. So those are some guilty pleasures from Dennis, and many of them overlap for me. Please feel free to write your own guilty pleasures into the chat, and we'll carry them forth. But Dennis says, you got rid of my other guilty pleasure. Ah, you're right, I didn't have that one in there. Rely heavily on implicit data conversions instead of thinking more about this. So as I'm sure you know, Oracle's really lovely about, let's just show you an example of an implicit conversion, though it's not really striking to the point that Dennis is raising here. I can write code like this in PL SQL and it works just fine. My count is a string. Count star is a number. I deposit it into this variable, which is a string, and Oracle PL SQL automatically implicitly converts it for me. In general, you want to avoid implicit conversions because they might cause errors. For example, you might have date format mismatches. You might run into problems around the optimizer, because if I do things like this, where, let's say, where my number column equals a string, then you get into all sorts of implicit conversions inside the SQL engine, and you might end up not using indexes that you thought you were going to use. So in general, you always want to do explicit conversions and minimize the dependency on implicit conversions. And Dennis asked, but what are my guilty pleasures? So this is where I must confess, I think I will be letting you down, because in hindsight, I didn't really pick guilty pleasures, just things that I really like enough, but we'll get into that. And here's a comment from Edith. The function calls can be made reconsistent by using a flashback query, but it's not easy to do that because of you need to catch the precise starting SCN, system context number, of the query. So yes, there are definitely ways to do it, but in general, you probably just want to avoid it. And if you're going to be calling functions inside your SQL statements, they're probably going to be, as much as possible, you want to make sure they're deterministic. So in other words, they don't have any external dependencies besides the parameter values coming in and the computation it produces and the value it returns. Just a generally good idea, but certainly you may want or need to do that, and then you need to take a hard look at whether or not it will cause a problem. Okay, so my sort of guilty pleasures. Well, first of all, I have just one enormously guilty pleasure of working with a language like PL SQL, a database programming language. The simplicity and readability of PL SQL. And I'll talk more about why I think these do qualify pretty well as guilty pleasures. Using packages, building APIs. No need to run any sort of build process or make with all of my code base. The power of AUTHID. Let's take a look. So a data API for data API language for data. So PL SQL is a database programming language. It's not a general purpose language. It was designed to basically support and extend SQL. And I think that is a very powerful idea and a very important one that is tended to be neglected and pushed aside in the modern programming world. So a couple of thoughts on this. One, data is really different from algorithms. So by and large, when we're writing code, we're writing algorithms, step-by-step processing, whether it's object-oriented or asynchronous, or sort of run-of-the-mill stuff that we do in PL SQL, do X, then Y, then Z, if X, then Y. So data is different from algorithms. Data, well, it just is. Data is information that's being put into our brains for processing, or to computers for processing. And we naturally, I think humans naturally process that data as sets and patterns. And I think that's the core reason that SQL and the relational model has such enduring power and popularity, because SQL is set-oriented. SQL is all about patterns and pattern analysis. A where clause is essentially defining a pattern where a certain set of rows follow this filter. That's a set of data. That's a pattern. And our brains are all about analyzing data, finding patterns, and then generating strategies for surviving and reproducing and thriving with those patterns. So I think that SQL actually syncs up really intuitively with the way our brains work. Conversely, it's kind of interesting that so many of us have trouble thinking in this set-oriented kind of way. And I think that's because most of our programming life is geared around non-set-oriented thinking and writing of code. But I think it also argues, getting back to PL SQL, for an intermediary programming language that is data or SQL aware. So you could say, well, I've got SQL, I'm going to use SQL, I've got Java, and we're just going to hook the two together. And we see the problems that people run into with that. For example, the need for ORMs. They don't really match. The Java model doesn't match the SQL model. We need something in between, and so we're going to generate the SQL for you, and you don't have to worry about it. And that's good in a way, because we do need something in between. But I think what we need is an actual intermediary programming language that was designed to be a data-smart language, PL SQL. And thank you so much for providing this language to us. So the guilty pleasure is that I suppose it's like living in this wonderful, safe, not safe zone, comfortable zone in which I can work with my database so effectively and so easily. And I can publish APIs, I'll get back to that via packages, and not have to deal with all the nonsense that Java developers and JavaScript developers and Python developers have to do when they want to make the most of their database. If they use PL SQL as a pathway to making the most of their database, they will be very far along fully leveraging the database. So I guess I feel guilty compared to all those other people out there struggling to work with SQL, and we have it so easy, relatively speaking. Proud pleasures and not guilty. You're right, Dennis. I didn't follow my own rules, but I'm glad you did. Simplicity and readability. Again, the guilty part is maybe I should not like how simple and straightforward PL SQL is. Maybe I really should be wanting to go into the JavaScript insanity of asynchronous programming and callbacks and React and this, that, and the other. Maybe I should, maybe I'm just too old. See all that gray? And there's no question that PL SQL can't compete with all these new approaches and capabilities of these modern languages, but I gotta tell you, boy, I like being where I am. I like being able to provide value, and hopefully you all feel like you're providing value as well in your actual customer sites by being able to leverage the simple, powerful, highly readable language. So it's true, PL SQL keep things simple, but it seems to me that allows us to focus on the task at hand, which is maximizing the security and performance and maintainability and integrity of our data. Packages, aka APIs. So APIs are enormously the rage these days, and it's easy to understand why. When you've got all these distributed systems that have to be talking to each other, the idea of having well-documented and well-designed interfaces between these systems that are easy to call, easy to use, and are very reliable is extremely important. If you don't have that kind of standardized interface, there's no way for all these pieces to work together. And of course, as I'm sure you've been seeing, things are getting really crazily complicated. It might just like fall on, just collapse on its own weight, all the software and complexity we're building, but probably not. We'll probably just be making it more and more complex and throw more and more resources at it and somehow keep it all going. So APIs are really important, but there's nothing new about APIs. And certainly packages, the core building block of PL SQL applications, of any Oracle database-based application, basically allow you to build clean and powerful APIs, not so much to front-end logic, but to the data and the business rules. And what makes this so powerful, and let's see, how can I make this sound guilty? I guess I feel guilty because I know what we can accomplish inside the PL SQL and SQL world, and I feel guilty that those folks out there aren't taking advantage of it. I haven't been able, yes, I feel guilty because I haven't been able to convince all those other people about the wisdom and wonder of using PL SQL. I have failed, and I feel bad. But the good news is that we can keep on building package specifications, and we can build REST APIs around those package specifications, so people don't even have to know that they're calling PL SQL. They just have to know that there's a backend they want to rely on, and here's a REST API with automatically generated Swagger doc out of the Oracle REST Data Services product, or its product, that they can then call. So as usual, you're talking about really multiple levels of APIs, even in the backend. You can think about SQL being an API to the data, though I think that's a bit of a stretch. Certainly packages on top of SQL, and then REST on top of PL SQL. And from there, you're probably pretty much talking about direct into the front end. So always use packages as your main building blocks for PL SQL applications, and take full advantage of the features in packages, for example, overloading, static polymorphism, having multiple programs with the same name, but different types, procedure versus function, or different parameter lists. Overloading is really great because you basically transfer the complexity of your API to the package body and the implementer of the package, and keep the API as simple as possible. So update a question, there might be 15 different update question overloadings for different scenarios. And your users of that API don't have to say, do I call update question 1 or update question 2 or update question 3? I just call update question. Pass it the list of parameters that are relevant for me, and the PL SQL package, the runtime engine, automatically figures out which one matches and calls that one, or tells you you've got an ambiguous invocation. No need to make. So this is certainly a pleasure of PL SQL. And one of the consequences of having code that's stored in the database, that's compiled and analyzed and put into the database. So we don't ever have to go through any kind of build process, right? We have an automatic, and as Bryn Llewellyn, PL SQL product manager, refers to it, completely reliable equivalent built into the database to make utilities. As I'm sure you know, the database automatically performs dependency analysis. It automatically invalidates program units that are dependent on objects that have changed. And then will automatically, whenever possible, recompile those objects to bring them up to speed, to bring them into sync. Also, starting with 11G, there's something called fine-grained dependency that reduces the need for invalidation. So basically, the dependencies are now tracked not on the object level, like package A depends on package B, but package A depends on package B subprogram Y and the parameter list in that program Y. And you can make changes to your package spec and not necessarily cause a ripple effect of invalidations through the rest of your application if you take time to design those programs well. And this, by the way, is another reason to use %row type and %type, going back to the varchar2 32767. So the more you anchor things, so instead of saying varchar, even the subtype of max varchar2, if this variable is getting the value from a column in a table, declare it as %type or declare it as %row type against the table or cursor, and then you get automatic dependency linkage. There's probably other linkages as well to those tables or columns, but this way you've cemented the connection even tighter. Let's see, we got a couple of comments here. From Peter, one thing I don't like about packages is that you can't compile individual functions or procedures. If your package is in production and one of the functions is constantly used, you'll have a hard time compiling. It's funny you should say that, Peter. I was doing a patch to the dev gym over the weekend, and for some reason, I stopped all the jobs. We have a number of jobs that kind of spin along, and we also stop people from doing most of their work on the website while we're doing an upgrade. And but for some reason, something was locking access to a couple of packages, and they timed out. Now, what I should be doing, as Sven mentions, of course, is use EBR, addition-based redefinition. So with addition-based redefinition, which is basically the ability to have multiple additions of your code base, and then you can switch between the additions, you can actually roll out changes to your application without any downtime at all. You have to do things on the front-end side to move people from one front-end to the other, if that's changing. But it is possible today in Oracle database to avoid the issue of downtime for patches and upgrades, and yet I have not done that for the dev gym, I'm sad to say. Another comment from Dennis. The thing is that PL SQL APIs, which are supposed to be wrapped by REST APIs using ORDs, need to be written in a different way, not traditional. Because, an example, pipeline functions can return loads of data, and built-in limitations and paginations for REST endpoints is a good idea. You'd feel guilty for returning 100 megabytes over a GET HTTP request with a huge amount of HTTP overhead. So that's a great point, Dennis. I think what it comes down to is that it depends on what that part of your API is doing. If you're returning one row of data, then I don't think there's going to be that much of a difference in terms of how you're writing the code. If you're returning many, many rows of data, for example, a pipeline table function, that is a bit of a different animal and needs closer attention. Bryn Llewellyn promised a session in EBR soon. I'm not sure if you mean on-site in Europe or not. But yes, Bryn has been going around the world doing like 6-8 hour presentations on EBR to teams and to public events. So hopefully we'll see EBR adoption growing over time. And at a minimum, I would say, if you're about to start a new application, even if you're not ready to commit to EBR on your application, what you can do is take the immediate steps at the start of building your application to make it ready to use EBR in the future. For example, you won't ever have applications working directly with your tables. There'll be a view on top of the table because the table can't be additioned. Some things like that. And Dennis is clarifying that Bryn Llewellyn promised to do an EBR session on office hours. Cool. I will talk to Bryn about that. that sounds great. And yes, as Judith mentions, there is a great resource by Oren Nachman from Israel. He goes under db-oriented.com, and he has a great series of resources on EBR. He's probably one of the world experts after Bryn. I also want to go back to one other thing. I'm sorry that I made a mistake and forgot to talk about one of Dennis's guilty pleasures. My God, I think it might be all the way. There we go. This issue of SQL versus PL SQL, SQL calling PL SQL calling SQL, quite difficult to catch. So one of the things I wanted to point it out here is that if you go to Live SQL and search for scope, PL scope, you'll find a lot of different scripts here that show you how to use PL scope, which is added in 11G and offers static, and it offers analysis of your code at the time of compilation and allows you to answer some very interesting questions. For example, you can say, use PL scope to find all the SQL statements that have hints. And there's not much to it. You basically turn on PL scope, compile your code, and then you can say, go to all the user statements that has a hint. So there's some very interesting questions that can be answered very simply, but some of them are trickier. And what you can also do with PL scope is find all the SQL statements that have user-defined function calls. So if you're concerned about this context switching between SQL and PL SQL, and people have just gone and done whatever they wanted, whenever they felt like it, putting calls to PL SQL functions all over the place, you can use PL scope to find those SQL statements. And you can take a look at this code when you've got a moment and give it a try. I believe that I did not implement the next step, and I encourage you to take it on as an exercise for the reader. So look for all those functions that are called inside SQL that have SQL statements inside themselves. I believe I have not done that yet, so that would give you that full round trip of potential problems. SQL calling PL SQL, calling SQL. So Live SQL has a number of scripts relating to PL scope usage that I think you'll find very useful. Also, if you go to my blog, Steven Feuerstein on plsql.blogspot.com, search for PL scope. I offer a resource center for PL scope with links to a lot of resources. With PL SQL, it's very easy to write SQL. It's very easy to put in all of your code and to some extent lose control over your application. And it's also really easy to write dynamic SQL execution, and that can lead to SQL injection. So there are all sorts of issues that come along with the ease and the wonderfulness of writing SQL in PL SQL. And AuthID is one of those features in PL SQL that, with just the inclusion of one little clause can have an enormous impact on the way your application works. And it's really good to know about. So AuthID provides a very simple mechanism to allow you to give you very tight control over your data and the way that you access the data through your APIs. And the basic idea is that there are two modes of operation. There's AuthID definer and there's AuthID current user. AuthID definer is the default, and it's probably what you're using and you don't even know it. So let's go back to my code for a moment. If I go to my package spec, let's see, do I have it in here? There we go, AuthID definer. So this is the default. You don't have to have it here. You could just say create package or create procedure, function, trigger, etc. And you don't have to have the AuthID clause, but the default is AuthID definer, and that means that when you run my code, let's say I create this package, I grant execute to you, when you use my package, it runs under my privileges. So that means, and the really wonderful thing about AuthID definer is that you can centralize all of your access to your data and all your privileges to access data into the schema that owns this procedure or package. And in fact, with 12c, you can actually assign roles to program units. So we have a very elaborate privilege control mechanism right now in place as of 12.2 and higher. So this really just scratches the surface. But the basic idea is that with AuthID definer, when you call my code, you have all the power that I have for the duration of that call, but you can only do what I allow you to do through my API. Of course, if my package has dynamic SQL in it, and then when you call my program, you're running under my privileges, you might be able to do something via dynamic SQL that we really wouldn't want you to do. And that's where you can look at locking things down further with two things, either AuthID current user or the new ability to inherit privileges, to not allow inheriting of privileges, roles for program units. But let's just focus on AuthID right now. My alternative is authID current user. And what this means is that when I compile the code, it has to resolve references to all database objects like tables and views according to the current schema. But when it's executed, I grant execute on this package to you. When you call my program, the engine wakes up and says, well, I don't care what select from employees meant at the time of compilation. I care about what it means at runtime, what it means to you, the invoker of this program, the current user. So basically at runtime, it wakes up, reevaluates references to your different database objects, and then goes on from there. So there's a bit more overhead of execution at runtime. But the advantage is that essentially it reflects back into your schema. So I create a package, I grant execute to everybody, but it's current user. When you call my program in my package, it basically doesn't, let's say it was delete from employees. It doesn't delete from my employees table, it deletes from your employees table. So for example, if you want a single code base that works with different sets of tables, every schema has their own set of tables, same names, etc., different data. The authID invoker rights is a great way to do that, current user. In addition, if you've got dynamic SQL and shared code, I create a package, it does execute immediate. You really don't want to make that authID definer. You really want to make it authID current user to force to restrict what can be done with dynamic SQL to that user and that user's privileges. And I point this out because it's just such a powerful aspect of PL SQL. With this one clause, you can completely change how database objects are, reference to database objects are resolved, and you get an enormous amount of security out of that. Now I'm going to go back to comments, questions. From Sven, did you, Steven, or anyone else on the call ever have the need for a cycle sequence? I have the feeling it should be a thing of the past and there's no real business justification for it. Sven, I have not used that. So I guess I would agree with you based on my experience, but I don't have any other insights beyond that. And Dennis says, well, this could be a guilty pleasure, the authID current user, because I never specify authID definer, you just assume it is the default. You know, that pretty much works, okay. But I think that I'd recommend that you start adding authID definer into your APIs. Among other things, you're being explicit about the path you chose to take to resolve references. And secondarily, you're also informing others who come along later that there is this feature, maybe they should look into it. And finally, if you use compile time warnings, it will warn you. It'll say, hey, don't forget to include your authID clause. So, you know, it's nice to include it because then you won't be bothered by warnings. And here's a question from Raj B. Is it possible to take a session on parallel processing execution of packages? Well, I'll take that down as a note to look at that for a future session. So parallel execution. PL SQL is not a parallel enabled environment language. So you can't inherently say, start running this, then run this, then run this, and run them in parallel. But there are things you can do to essentially mimic that with advanced queuing, DBMS parallel execute, which is a built-in package for dynamic parallel execution of DNL statements. But I'll take that as an advisement to take a look at that in the future. Raj, thanks. And in terms of, we had a question that came up in advance for office hours, and I thought I'd bring this up after my work with authID. So actually, some of you might have more thoughts about this than I did. The person wrote a question asking, you know, why if I use, if I reference a database view, it's telling me I don't have access to that view 942, even though I can select from it, with or without authID current user. And basically, what I wanted to remind you about here is that there are two things. One is that when you compile a stored program unit, you always need directly granted privileges. So going back to my piece of code here, let's say that I define this to be authID current user, and I've got a table in here, table in my package body that, let's see the employees table. Even though it says authID current user, when I compile this package, it has to be able to resolve the reference to employees according to my current schema, not the schema that it's going to be using eventually. It's got to be a valid piece of code. So, but in runtime, because it's current user, you will never look at the employees table owned by that owner of the schema, which leads you to sometimes doing things like creating dummy objects. I'm going to create an empty employees table just to get it to compile so that at runtime, I can then resolve the reference to the appropriate employees table in the current schema. The bottom line, though, is that there's no escaping the fact that at compile time, you have to have directly granted privileges, not role-based privileges, which is why this kind of question often comes up. Now, what I didn't understand about this question is that he was having a problem with all objects. He was getting a 942 table review does not exist. And I really couldn't see why, unless there was something wrong with the schema, the way it was set up, that you would not have access to these data dictionary views. If any of you have any thoughts on that, like why you wouldn't be able to access those data dictionary views, I'd love to hear it. And a comment from Judith while you're all thinking about that. I don't see any reason for using authID current user as long as the PL SQL code is accessing the same database objects for all the callers. It's a great feature though when we need to access different physical objects, possibly even in different databases. I'd agree, Judith, that one of the main use cases for current user is that you're not going after all the same database objects, that it's being resolved to a different database object with different privileges. The other aspect of authID current user, and this is part of Bryn Llewellyn's SmartDB architecture in terms of really locking down your database and ensuring high levels of security, is that when you make it authID current user, it's much harder for that user to sneak in and do something that they shouldn't be able to do. And so you're basically forcing it to reflect back into their scheme and only the privileges granted to them. So even if it's a single set of database objects, maybe they shouldn't even be able to see or use that particular object. So there would be an advantage there of using current user. And all of this kind of comes back to what I think is one of the really wonderful and amazing things about PL SQL. So I'm going to go all the way back, let's see. So I think, again, maybe it's not a guilty pleasure, maybe it's just a pleasure. But it's very interesting to realize that if we make use of PL SQL properly, and I suppose properly from this perspective would be the SmartDB paradigm that Bryn Llewellyn has promoted heavily with Tim Kopelars. There is an office hours session on SmartDB. There are resources. I have a SmartDB resource center post in my blog that you can check out. But here's the interesting thing about following the SmartDB paradigm, taking advantage of all these aspects of PL SQL. You can actually guarantee a high level of data integrity and security of your data. Not, oh, if only the developers follow the rules, here's a document that says do these 10 things, and then we'll have a very secure database. You can actually force it to be secure. You can make sure that nobody can break through what, as Bryn calls, the hard shell of code around your data. And that's an enormously powerful statement to make. And maybe I'm feeling guilty because others cannot do that. If you write JavaScript against the database, against SQL directly, if you write Java, Python, etc., against the database directly, SQL, without PL SQL in between, you will not be able to offer the same level of performance and security and data integrity that you will if you use PL SQL. And that is probably the most important reason to use PL SQL, and the thing that we should be most proud of, and the thing that we should remind our UI teams, if you have the opportunity to work with non-database development teams, right? So Java developers, JavaScript developers, Python developers, writing against the database, make sure you make them aware that if you can step in and provide this API around the SQL, not have them do the SQL directly, at least the DML side of it, you can provide 100% guarantee around data integrity and data security. Nobody breaking in, no SQL injection possibilities. This is actually possible to guarantee, but not without PL SQL. And that perhaps is the most pleasurable aspect of working with this language and offering its APIs to others. Sven also mentions, I'm always too lazy to write sys in front of sys.dbms output. Very interesting point. Let me touch on that real quickly. It's another one of those, you're right, it's a great guilty pleasure. Let's see. I don't even think oh, there we go. Okay, I was thinking, I don't even have calls to DBMS output in my backend. This should be QDB utilities put line. I put a mask, I put a layer on top of DBMS output.put line in my code. I try to never use it in my production code. But in any case, let's go back to the original. The recommendation from Bryn around ensuring your code or protecting your code as much as possible from SQL injection is to always preface references to sys-owned objects, like all the built-in packages, with sys dot. And there's no question that this is really, really important. This is a really good piece of advice. Why? Well, if somebody manages to get access to your schema, they snuck in through some backdoor, some SQL injection point that wasn't protected, they can actually execute, create or replace package DBMS output and replicate the API for DBMS output, including all the put line calls. Well, there's just one. And then create their own package body that says, for example, when you call DBMS output.putLine, you're going to call my DBMS output.putLine, and I'm going to delete everything in your table. So that's one of the dangers of injection. Of course, once they get in, they can create all sorts of problems, and they can actually take over references to built-in packages in your schema. But if you preface every reference to a built-in package with sys. With the owner of the package, they can't do that because, of course, your DBMS output.putLine is not the same as sys.dbms output.putLine. So it's one of those pieces of advice that is unassailably true. There's no question that your code will be better off if you put sys. In front of all of your built-in packages, and I don't remember to do that. You could say, well, I don't want to hard code sys because Oracle might change it. No, Oracle's not going to change that. So great point. Thank you. And that's a good ending guilty pleasure as well. So thanks everybody for joining me today. I hope you had fun. I hope you appreciate PL SQL even more than you might have already.